This is section 7.02 of the Unit 7 notes, direct and inverse variation. Today I am, as in you are the student, discussing direct and indirect variation so that I can determine the constant of variation and write variation equations. I will know I have it when I can successfully write and solve direct and inverse variation problems. Specific TEKS we're looking at for today's lesson is 5A. Direct variation. I'm going to cover some of this and then reveal it as we go. Direct variation, the relationship between the input and output of a function. In this particular case, as x increases, y also increases, or as x decreases, y also decreases. So in terms of a real world scenario, as something is increasing, not just x or y, as a particular value is increasing, the other value associated with it is also increasing. So those two things are directly related to each other. As one increases, so does the other. And then in the other direction, if one thing is decreasing, the other is also decreasing. So that's what a direct variation means for a function. So we say that y varies directly to x. This phrase is important when having to look at word problems. Y varies directly to x. So what does this mean? There are two types of formulas we're going to be looking at. A formula that represents a line, y equals kx, where k is the constant of variation, and a formula that finds the k value, which is k equals y divided by x. So k, the constant of variation, the constant that multiplies into the x value, can be found by taking the y value and dividing it by the x. In some of the problems we're going to be seeing, you're going to have a few different values already there for you. You then will have to find different components of the formula to create it. For example, you're going to try to find the k value in one example, and then from the k value, enter it into the y equals equation to get the general direct variation formula. Now, what does this look like on a graph? Looks like a linear line. From left to right could be going either up or down. So some examples of that is negative 3x for the downward variation. And then some positive examples are y equals 2x or y equals x in general. So these are examples of direct variation. Again, I'm going to cover the steps here and then reveal them as we go. But here's an example. Excuse me. Suppose f of x, another way of saying that is y. So suppose y varies directly with x. And f of x, which is another way of saying y, is equal to 24 when x is equal to 2. What is the value of f of x when x equals 6? So, varies directly gives us a hint on how we're going to solve this problem. So, varies directly implies that we're going to be using direct variation. Whenever direct variation comes into play or gets brought up, there's two equations that you have to think about. Y equals kx and k equals y divided by x. So what is the value of y when x equals a 6? Well, in order for us to figure out anything, we need to first develop the k value, the constant k. And we do that by using the first two numbers that we see right here. F of x is equal to 24 when x equals 2. It gives us the rule. It gives us the direct variation, how they're related to each other. We're going to use one of the equations to find k. So now remember, k is y divided by x. So we know the y value, 24, and we know the x value, 2. So 24 divided by 2 is 12. So k equals 12. Now we're going to use k and f of x and x that go together to set up the new equation. So y equals kx. The new equation is y equals 12x. Okay. Now from there, we're going to use the last value here, x equals 6, to plug into our new equation to solve. So x gets replaced with 6. Y equals 12 times 6. What's 12 times 6? I believe that is 72. Yep, and there you go. So y equals 72. And that is the final answer. What is the value of f of x? In other words, y when x is equal to 6? Well, y is equal to 72. And again, notice how we use the k formula first to find the equation right here. And then from the equation, we plugged in the x value to then find the corresponding y value. And we knew to do this because it told us that f of x varies directly with x. So we know automatically to pull up these two equations to solve. Okay, you try number 1. What is the value of, let me back up a bit. Suppose f of x varies directly with x, and f of x, which is the same as y, is equal to negative 10 when x is equal to 2. What is the value of f of x when x is equal to 12? So step 1, use one of the equations to find k. K equals y divided by x. Fill in the formula and find k. Use the k value to plug into the first equation, y equals kx, and find your new equation. Then plug in the x value from the last one and solve. So you're going to use the k value and the x value, multiply them together, and you will get your final answer, f of x, or y equals. If you're on ClassKick, you can move this box to try and check and see if you're doing everything correctly. Otherwise, I would ask for y'all to pause the video, answer this in ClassKick or on a piece of paper, whatever it is you're doing while watching this video, and see if you can get the answer. Otherwise, I'm going to go ahead and show y'all how to do this. So, we need to find the k value. We know f of x, which is the same as saying y, is negative 10. We know the x value is 2. So to find the k value, we use the first set of numbers, and we know that varies directly means we're going to divide them. So negative 10 divided by 2 is negative 5. Use that to plug into the first equation, and now we have y equals negative 5x. We are then going to plug in the new x value, 12, and find the answer from there. So negative 5 times 12 from the new equation that we built should be negative 60. And that should be your final answer. And you can see right there, that's it. That's it for you try number 1. Okay, another example. Total distance traveled, d of t, which again is just another way of saying y, varies directly with the amount of time spent traveling t. So we got two variables here, d of t and t, which again, d of t is the same as saying y, and then t is acting as our x value in this case. Doesn't matter whether you use y, x, d of t, t, but just so you know which one's which, there's that. If traveling for 4.5 hours results in 180 miles traveled, write the equation that can be used to find the distance traveled for t hours. So we're not trying to evaluate anything, we're instead trying to build the equation. So we need to see how all of this relates to, or how we can get all of this and use it to our direct variation equations to build the equation. First off, we know varies directly means we're going to be using those two equations from right here. Y equals kx and k equals y divided by x. So we got to remember those two formulas, those two equations. First step is to use one of the equations to find k. Well, the easiest way to do that is to get k equals y divided by x. Now, what is y in our case? D of t, distance traveled. So the distance traveled is 180 miles. Now, what is x in this case? X is t. T represents time spent traveling. So that's 4.5 hours. So we're going to divide this by 4.5. Now, do the math. 180 divided by 4.5 should give us 40. Therefore, k equals 40. The k, the constant of variation, is 40. Now, use k to write the equation. So we're going to use the other one that we didn't use, y equals kx, and then fill in for 40. Or fill in the k with 40. So again, y equals kx. K is 40. Remember, in this particular scenario, x is actually t and y is d of t, just so you know for your multiple choice answers on the quizzes, if you see anything like this. So d of t is equal to 40t. This is the equation that can be used to find the distance traveled for t hours. Okay, that's it for this example. Now there's another U-try. U-try number 2. The number of calories in a bag of chips, C of n, remember C of n is the same thing as y and n is the same as x, varies directly with the number of chips in the bag, n. If an individual sized bag of 15 chips contains 270 calories, which equation can be used to find the number of calories each chip, n? So here are the steps. Step 1, use one of the equations to find k. K equals y divided by x is the fastest way to do that. Use the k to write the new equation. So then use the first equation, plug in for k, and there it is. So you try number 2. Go ahead and pause the video. Try this on your own. If you are on ClassKick, you can move this box right here to check your work. So take the time right now to try this problem. Otherwise, I'm going to go ahead and show y'all how to do this. So again, C of n is the same thing as saying y, and n is the same thing as saying x. We have an individual sized bag of 15 chips. So the amount of chips, 15 chips, that's associated with n or x. And then 270 calories, that is the y value, or C of n. Okay? I'm just going to write here in blue. This also represents x, and this represents y. So now we want to create the equation, but first we need to find the k value. So we're going to use k equals y divided by x. Y in this case is 270 calories. N value, the x value in this case, is 15 chips. So this is 270 divided by 15. 270 divided by 15 is equal to 18. So the k value is 18. Use the k to write the new equation, y equals 18x. Or if you want to write this in terms of what the word problem said, this is C of n is equal to 18n. And then just to show you what the answer is, there it is. That's it for you try number 2. Here's another example. This is going to involve graph points of a direct variation problem. So you're going to be presented with graph points, and you're going to need to see which one is associated with the equation that it comes from, or that not that it comes from, that we're focusing on. So, for example, we have an equation up here. You're going to be given a set of points. From those set of points, you need to determine which one is an actual direct variation, has a direct variation relationship by plugging it into the original equation and see if they equal each other. So here's what I mean. Here's what I mean. For this example, determine which point is on the graph of a direct variation equation in which k equals 0.4. So if we know what k equals, then we know that for a direct variation equation, for y equals kx, the equation will be y equals 0.4x. Now, to determine whether these are direct variation points, we need to plug them into the equation right here. So now we're going to substitute x with 4, and we're going to substitute y with 10 to see if this coordinate is a direct variation that's related to this equation. Excuse me. So to do that, y turns into 10. So again, y turns into 10, and x turns into 4. So the left side, 10, is good. But now the right side, let's calculate to see if it equals to 10. So 0.4 times 4. No, this is equal to 1.6. And to put it simply, 10 does not equal 1.6. Therefore, the first point is not a direct variation, or at least not associated to a direct variation where k is equal to 0.4. So now let's try the next one. 10, 4. 10 comma 4. So we're going to type in, or we're going to plug in y with 4. And then we're going to plug in 10 with x. So now 0.4 times 10 is 4. Therefore, 4 equals to 4 is a true statement. 4 equals 4. That's why you see yes for this point as an answer. Now for the last one, just for the sake of it, we're going to check this last one. It's 10, that should be a comma. So 10 comma 0.04. Type those in. 0.04 is on the y. 10 is on the x. The 0.04, we're good. We don't have to do anything to it. But the right side, we're going to multiply and see if it equals on the left side. So 0.4 times 10, it's equal to 4. So the result is 0.04 is equal to 4, which is not true. Not true. And so the last one is not a direct variation associated with a k constant, 0.4. That's how we would do a problem like this. All right, that's it for this example. You try number 3. We have something that's similar to it. Which point is on the graph of a direct variation equation in which k is equal to 3? So if k is equal to 3, from this equation right here, you have y equals 3x. Using that equation, you're going to test each of these points to see if they equal the same number. So go ahead and pause this video. Try this problem on your own. If you need help, you can move this box right here to see if you're doing everything correctly. Again, if you're on ClassKick, you could try this problem on your own. Otherwise, I'm going to move forward and show y'all how to do this. Okay, so the equation we're using to test out each of these points, y equals 3x. So for this first one, y is 5, x is 2. Y value, you're going to type in 5, and then you're going to plug in x with 2. So 3 times 2 is equal to 6. 5 equal to 6. Not true. Therefore, A is not the answer. Letter B. 6 is the y value. 2 is the x value. 6 equals 3 times 2. 3 times 2 is 6. That's good. So far, that may be the answer. Let's check the rest. 3 is the y value for letter C. And then 4 is the x value. 3 times 4 is 12. 3 equals 12. Doesn't make sense. C is not our answer. Letter D. X is 3, y is 1. So 3 times 3 is 9. 9 equals 1. Not true. Therefore, the only answer that makes sense is letter B. That's it for you. Try number 3. Okay, so those previous 3 problems were related to direct variation. Now we're going to go into something called inverse variation. And again, the variation is the relationship between the input and output of the function. So now, previously, direct variation, as x increases, y also increases. Or as x decreases, y also decreases. Inverse variation flips that around. So as x increases, y decreases. Notice the change for inverse variation. Or as x decreases, y increases. Notice how they're opposites now. If x is going lower, y is going higher. As x is going higher, y is going lower. So they're going in opposite directions this time. Direct variation, they were going in the same direction. Inverse variation, they're going in opposite directions. Okay, so y varies inversely to x. That's important for word problems. When you see y varies inversely, we're going to be using the following 2 equations. Notice how they're super similar. They just got flipped around. So the inverse equation is y equals k divided by x. And then the k equation, the constant of variation, is k equals x times y. And notice that the graph, they follow a different line. This is more exponential than it is linear. So it's got a bit of a curve and then it flattens out. And again, look at direct variation. Direct was y equals kx, and then k is equal to y divided by x. And then inverse is y equals k over x, and then k equals x times y. So they are different. However, a lot of the problems are going to be the same, trying to solve them. You just got to make sure you pay attention when they say either it varies directly or it varies inversely. That'll tell you which set of equations you need to use to solve the problem. So in this example, again, let me cover this so that I can teach it to y'all. Suppose f of x, which is another way of saying y, varies inversely with x, and y, or f of x, is equal to 3 when x is equal to 10. What is the value of f of x when x equals 15? So, varies inversely gives us the hint that we're going to be using these two equations. Excuse me. Y equals k divided by x, or k equals xy. Now, in order to solve this inverse variation problem, we first need to know what the constant variation is, meaning we need to find the k value. So we're going to use one of the equations to find the k. Typically, the second one is easy. You can use either one, but the second one is easier for y'all. So to find the k value, we're going to use the first two numbers that were given to us. F of x is equal to 3, so that means y is equal to 3, and then x is equal to 10. So then typing that in, 10 times 3 is 30. K is equal to 30. Then use k to create the equation. That's going to be y equals 30 divided by x. And there's our new equation. Now that we have our new equation, we need to know what the value of f of x, the value of y, is if x is equal to 15. So, from the new equation, x gets replaced with 15. 30 divided by 15, type that into the calculator, or do it in your head, is 2. Therefore, when x is equal to 15, y is equal to 2. And that's it. You try number 4. Try this problem out on your own. Let me read it to you first. Suppose f of x, again, another way of saying y, varies inversely with x, and f of x is equal to 0.75 when x is equal to 8. What is the value of f of x when x is equal to 2? Step 1, use one of the equations to find k, typically the second one where k is by itself. Step 2, plug in the x, plug in the f of x, you'll get your k value. Step 2, plug in the k value into the first equation to get your new equation. And then from there, use the last number, x equals 2, to find your final answer for y. If you're on ClassKick, you can move the box to see if you're doing all these steps correctly. So at this moment, go ahead and pause the video, try this problem on your own. Otherwise, I'm going to continue on and show y'all how to do this. So varies inversely automatically means I'm going to be using these two equations, y equals k divided by x, or k equals x times y. First, we need to find the k value. We have that y equals 0.75 when x is equal to 8. So we can use those two to multiply together to get the k value. 8 times 0.75. I think it's 6, but let's see. 8 times 0.75. 6. There we go. So the k value is 6. Plug that into the first equation you didn't use. Y equals k divided by x. And then y equals 6 over x. That is our new equation. Now, what is the value of y when x is equal to 2? Well, using our new equation, k divided by 2 will be 3. Therefore, y is equal to 3 when x is equal to 2. Yeah, there we go. All right, that's it for you try number 4. Here is a word problem example. Cover this up. So the time y it takes a train to reach its destination varies inversely with its speed x. The train takes 3 hours to reach its destination when traveling at 50 miles per hour. Write the equation that can be used to find the speed to make a trip in y hours. So we want to write an equation. Well, notice we have time y, so it's giving us some labels here, and we have speed x. The train takes 3 hours. 3 hours is associated with time. So this is a y value. To reach the destination when traveling at 50 miles per hour. Miles per hour is a speed. Therefore, this is an x value. Now, using this information and the fact that this varies inversely, we're going to write an equation that can be used to find the speed to make the trip in y hours. So first, we need to find the k value. We know varies inversely means that k is equal to x times y. We have x, we have y. So in order to find the k value, you need to multiply x, which is 50, with y, which is 3. 50 times 3 is 150. Therefore, k is equal to 150. Now that we have the k value, the next part of the question is to write the equation that represents this. So the equation is y equals k divided by x. What is k? K is 150. Therefore, the final part of the question is, or answer, is 150 divided by x. Now, if for whatever reason they wanted the x and y value on the other side, you can also just replace the second equation with 150 and then leave the x, y by itself or on the other side, and it's the exact same thing. But typically, you'll see the answers in y equals a fraction. That's it for this example. You try number 5. The time it takes to wash all the windows on a large building, W of X, varies inversely with the number of workers assigned to the job, X. It takes 6 hours to complete the job when 4 workers are assigned to it. Which equation can be used to find the time to complete the job when X workers are assigned to it? Step 1, use one of the equations to find the K. Typically the second one, K equals X times Y. Fill out the values and then find the K value. Use the K value to then write the new equation. So using the first equation that you didn't use, plug in the K and there's your equation. Or if you wanted to, as an alternate answer, you could just say K equals X times Y. You could just plug in the K value there. Same thing. And that's it. So I would like for y'all to pause this video, try this problem on your own. You can move the box right here if you're on ClassKick to see if you're doing everything correctly. So go ahead and pause the video, try this on your own. Otherwise, I'm going to continue on and show y'all how to do this. So W of X is our way of saying Y. Represents the time it takes to wash all those windows. The number of workers is associated with the X value. So now, it takes 6 hours is associated with a Y value. 4 workers is associated with an X value. We also know that this varies inversely. So knowing that information, we need to create an equation that represents the scenario. Since this varies inversely, we know we're going to use y equals k over x and then k equals x times y. First off, we need to find the k value. We know the x value is 4. We know the y value, or the w of x value, is 6. So 6 times 4 is 24. Therefore, k equals 24. Now take that number, use it for the construction of your equation. Y equals k divided by x. Therefore, y equals 24 divided by x. Or instead of y, you could also say w of x is equal to 24 over x. Or you could just say 24 is equal to x times y. Same thing. There's your answer. Okay, that's it for you. Try number 5. Here's another example. Let me just cover some things up so that I can teach it. The time y it takes a train to reach its destination varies inversely with speed x. The train takes 3 hours to reach its destination when traveling at 50 miles per hour. What must the speed be to make the same trip in 2.5 hours? So varies inversely. Again, we know to use the two different equations, y equals k over x or k equals x times y. We need to identify some things first. We know that time is equal to y in this scenario, and then speed is equal to x. 3 hours is associated with the y value. 50 miles per hour is the x value. What must the speed be to make the same trip in 2.5 hours? So first off, let's find the equation. Let's find the k value to construct the equation. We know k is equal to x times y. X is 50. Y is 3. 50 times 3 is 150. So create the equation. Y equals k divided by x. And so we have y equals 150 divided by x. Now, what is the speed? What must the speed be to make the same trip in 2.5 hours? So 2.5 is associated with the y value. So here's the next step. Now we can use either the left or the right. Going through this problem, I decided to use the right instead because it's an easier way to solve. Because I would only have to do one step, and that's to divide. Here, if I use this first equation, I would have to switch some things around and perform 2 steps essentially. This one, you only have to think of one way. So I'm going to use 150 equals 2.5x. Again, notice how I use the second equation and replace y with 2.5. Then, to get the x by itself, divide by 2.5 on both sides. Right sides are going to cancel. And then the left, let me write that a little bit better. The left turns into 150 divided by 2.5. Plug that into your calculator. 60. Therefore, the train must travel at a speed of 60 miles per hour to make the trip in 2.5 hours. If you wanted to see how we did it with the first equation, I could do it right here. This will be 2.5 is equal to 150 over x. I would do something called cross multiplication. I would cross the x and the 2.5 and switch them to get x equals 150 divided by 2.5, and you're still going to get the same result from there. But either way, it does not matter. Okay, you try number 6. The time it takes to wash all the windows on a large building, W of X, varies inversely with the number of workers assigned to the job X. If it takes 6 hours to complete the job when 4 workers are assigned to it, then how long does it take 10 workers to wash the windows? So step 1, use one of the equations to find the K value. Typically the second one is the easiest. Step 2. Well, after you plug in the X and WX values, you'll get the K value. Step 2, plug the K value into the equation and get your answer. Get your equation. Step 3, plug in the new value and solve. So now note, well, I won't say anything. I'll just let y'all observe and see if y'all could do it. Plug in the values and then get your final answer. Move this box to see if you're doing things correctly. So go ahead and pause this video. Try this problem on your own. Move this box to see if you're doing everything correctly. Otherwise, I'm going to continue on and show y'all how to do this. Excuse me. So WX. W of X represents time. Number of workers represents X. Time is Y. Number of workers is X. If it takes 6 hours, which is Y, to complete the job with 4 workers, again, that is the X, workers, then how long does it take for 10 workers, an X value, to wash the window? What do? Well, we know this varies inversely. Therefore, we have 2 different equations. Y equals K divided by X, or K equals X times Y. Let's first find the K value. K equals X times Y. X is the 4. Y is the 6. The first couple numbers that we see. 4 times 6 is 24. Plug this into the other equation. Y equals K over X, and then we have Y equals 24 over X. Now, how long does it take for 10 workers to wash the window? What is 10 associated with? X. And so that's why we're using the fraction version. K is 24. X is at the bottom, which is 10. Excuse me. 24 over 10. There's nothing we have to do to switch it around. It's already there for us to solve. So that's why we're using this and not, for example, 24 equals 10x. You can still use that. Oh, I'm sorry, not 10x. 10y. You can still use this and then divide 10 on both sides. And you're still going to end up with the same problem. But using the fraction version saves us that extra step. 24 divided by 10 should be 2.4 hours. And there we go. So for 10 workers, it takes 2.4 hours to wash windows. Remember, y is the same thing as saying w of x. And that's it for you try number 6. Okay, that's it for this video. If y'all need anything, let me know. You know y'all have my information to contact me if y'all ever need anything. Make sure you're using your notes for your quizzes and tests. If y'all have any problems that you need me to go over again, or that y'all need extra help with, shoot me an email, send me a message through my phone, whatever, okay? Y'all have a good one. Take it easy, everybody.